In this episode, I'm going to do a basic service on an old Marantz 1120, which is an American-made amplifier, integrated amplifier. And this one here just needs some basic tune-up and check over. Nothing really wrong with it, other than the controls itself need some attention. And I think the pilot light's out, so we're going to give this one a basic once-over and see how it is performing. Well, it doesn't have much in the way of sound, does it? So here's the inside of this old Marantz. As you can see, it's a modular design with separate boards. Outputs are back here. We know the outputs are okay because there is sound, but there's very low sound. So we have to look into the preamp stage on this and see why the sound levels are so low. As you can see, this has got exposed switches, so these should all be cleaned, as are the controls at the front here. These all need to be cleaned as well because you can hear all the noise in there when I move the controls. First, I'll start out with cleaning the actual switches. Oh, I think I see why the volume's low. Oh, muting switch is on. Oh yeah, now this thing's got some volume. I gotta clean these switches too on this thing. Okay, now that the controls are cleaned.
Oh yeah.
course, I can't leave that one on, but I can this one. This one being royalty free. One's coming from my, okay, you can definitely hear the sound quality too. This is coming from my little MP3 player back here. This thing. And the other source is coming from a CD player, but it's actually playing an MP3 CD. But the MP3 decoder in this little KPI CD player that plays MP3 that I picked up for $7, the actual MP3 decoder is superior and it just has much better sound. It might be just this song too that's playing. Try a different one here. Because it might have just been that song. But that song that was from a royalty-free download didn't seem to have very good sound, but the pilot light's burned out. I was going to replace the pilot light, but check the voltage across here. Now, obviously, this is because there's obviously a dropping resistor on here, but they just taken it across the full 43 volt supply, which is probably what the caps are. Yeah, plus and minus 43 volts is what the working voltage of this amplifier is. So about 86 volts between the positive and negative supply. So the bulb is actually just taken off of a direct tap off of one of the main power supplies, and they're just using a dropping resistor. So I'll have to put another big dropping resistor in if I want to convert this to an LED, or I can just replace it with an incandescent bulb. It's probably a 12 volt bulb that was in there. So I'm going to change the light for an LED, just a white LED. It doesn't need to be that bright because it is just a power light. And it shines through a little blue lens on the front here. And I've just gone with a resistor value here. What did I pick? I just grabbed anything out of the toolbox, and it's a 5.8K, because it's feeding off a fairly high supply to begin with. But there's obviously going to be a current limiting resistor on here to begin with, because this would not be a 42 volt light bulb. It would be a 12 or a 9. So there's already an unknown value of resistor that I'm not going to bother to investigate to figure out what it is. Doesn't matter. I only need to draw a few milliamps through this LED to light it up, and I think this resistor value will do just fine. So let's remove the old bulb first. So we'll just unsolder that from the chassis. There's the old bulb out. And it just pushes through this thing. Probably break when it comes out because it's probably been in here so long that no, it didn't. A lot of times the glass will break because the bulbs have been in so long that they've actually fused themselves to the rubber grommet. Okay, new wire here and new bulb. We'll pull the grommet out first. Put the LED into the grommet. I'm just going to solder it down first, and then we'll push the whole thing in. Oh, you're not going to believe this. The holes drilled through the board for the wire, for the little light bulb, are actually too fine for these wires, for this resistor and a piece of Cat 5 wire to fit through. So I'm just going to attach them on the back side of the board, and we'll keep them separated. I'll put some heat shrink tubing around one of them just to keep the bare conductor from making any unintended connections. So let's see how that looks for light. Ah, I believe that's more than bright enough. Okay, so what we'll do now is I'll just bring this around, put it in the grommet. So you can see the power supply continues to run for quite a while. And we'll just put the wires over top like that, and then that will insulate to make sure that the bare wire from the resistor doesn't make any unintentional contact with the board. For that matter, I can hit it with the heat gun, shrink the tubing down so that it can't move. There. And this other wire being insulated is not going to pose any issues. And there's clearance between the top cover and this anyway, so it's not going to pinch anything. Right, there's a little bit of clearance here. The top cover fits over top of this, so no chance of anything touching. And when I turn it on, it's beautiful. It lights up a nice blue. Let's take a look from the front. So here it is. Let's turn on the power. Beauty. Yeah, definitely the MP3 decoder in the CD player definitely sounds better than my little $5 MP3 player. I mean, that sounds okay, but it doesn't sound as good as the real thing. And same with CDs. CDs sound superior, but for testing, it's fine. Final test. We'll play some vinyl on here. Get down to be a bit funky here. Can't play this for more than a few seconds, but it's gonna be good. Some classic Chick Corea. Return to Forever. Gotta love it on vinyl. Well, that just about does it for this one. Hope you enjoyed this video, and we'll certainly catch you again real soon. Thanks for watching.